Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with another AMC Problem of the Week video. This week's video comes from the year 2022, 10B Problem 15, and it deals with arithmetic sequences. I hope you guys enjoyed this video and let's get started. The problem states, let Sn be the sum of the first n terms of an arithmetic sequence that has a common difference of 2. The quotient S3n over Sn does not depend on n. What is S20? So it tells us that Sn is the sum of the first n terms of an arithmetic sequence. So we know that the formula for the sum of the n terms in an arithmetic sequence would be n over 2 times 2a, where a represents the first number in the sequence, and then d is the common difference. So we can plug in d because we know that it is 2, so it would be 2a plus n minus 1 times 2. And then I'm going to expand this to get n over 2 times 2a plus 2n minus 2. And then because this is multiplying, so technically it would go up top with the n. And I'm going to take out a 2 from here and it'll cancel out with the 2 in the denominator. So that leaves us with Sn equals to n times a plus n minus 1. So this is Sn. Well, what is S3n? Well, we can simply just plug that in to get 3n times a plus 3n minus 1. And the most important part here is that we are told that the quotient does not depend on n. So what that means is that you can plug in for any number, 1, 2, 3, or 5, it doesn't matter, but it's not going to affect what the quotient of S3n over Sn equals. So then from there we can know that the quotient must be a constant. Because right now we can look at the ratio, we can look at the quotient. So S3n over Sn is equal to 3n times a plus 3n minus 1 over n times a plus n minus 1. Now I'm going to cancel out the n to get 3 times a plus 3n minus 1 over a plus n minus 1. And I'm just going to set this to be equal to k. So k is just a letter that I'm going to use to represent the ratio. So if k does not depend on n, then that means that k is going to stay the same no matter what n is. So that means the inner fraction here, because we have a 3, so we can take out the 3 to get 3 times a plus 3n minus 1 over a plus n minus 1. So this inner fraction right here, it must be a constant, not changing with n. So we're going to focus on this inner fraction right now. We see that both in the numerator and in the denominator there is a minus 1, so I'm going to set a minus 1 to be equal to c. It's just easier so we can simplify the ratio. So it would be c plus 3n over c plus n. This is equal to k, which is equal to a constant. Now, if we know this is a constant, if it's a number, then that means that the numerator and denominator must grow, or it must change at the same rate when n increases. However, right now we see that as n increases, the numerator, c plus 3n, is going to grow 3 times as fast as the denominator, c plus n, because of the number 3 that we're multiplying with the n. So that means that the only way to keep it a constant is that c must be equal to 0. Because when c is 0, then that means that will simplify to 3n over n. And this gets reduced to 3. So when c is 0, we do indeed get a constant 3. And that satisfies what we want. So that means we know that c is equal to 0, so a minus 1 is equal to 0. So a is equal to 1. Keep in mind that a is the first digit in the sequence. And so we can plug back a into this equation right here to get Sn. So Sn is equal to n squared. So that means that the sum of the first n terms is n squared. So if we want to know what S20 is, and that's simply just 20 squared, which is 400. So the answer is D, 400.